Okay, hi, welcome. So today I'm going to explain derivatives of polynomials and exponential functions. So if you recall what we did in chapter 2, we basically have that the derivative, at the definition of the derivative as limits. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we're going to use this definition of the derivative to find the derivatives of polynomials. But let's just clear this out. In terms of notation, sometimes you're going to see f prime of x. Sometimes it's going to be y prime. Other times dy dx or df dx. So those are just, they all mean the same thing. So let's start with the derivative of polynomials. Rule number one is a power rule, right? So if you ask to find the derivative of x to the nth power, what you do is basically you take the exponent and you drop it in front of x, and then you write x times, then you go to the old exponent, you take away 1 from that exponent. So the derivative of x to the nth is n times x to the n minus 1. For example, if you're asked to find the derivative of x squared, then it's going to be 2 times x raised to 2 minus 1, which becomes 2x. So y prime equals 2x. If n is 2/3, then you do the same thing. So y prime is going to be 2/3 times x raised to 2/3 minus 1, which gives you 2/3 times x raised to negative 1/3, which when you bring this, you want to make this you want to express x term as a positive exponent, you can bring it downward, you can bring it at the denominator to become 2 over 3 times x to the 1/3. This time n is negative 2, so you do the same thing. You drop negative 2 times x raised to negative 2 minus 1, which gives you negative 2 times x raised to negative 3, which you can write as a negative 2 over x cubed. Now this time, they ask you to find the derivative of f of x, which is the square root of x. You see now there's no, n is not clearly expressed. So your job is to change the square root to the fractional exponent 1/2. So f of x equals x to raised to 1 over 2. So n is 1 over 2. So again, you apply the power rule. So you drop 1 over 2 times x raised to 1 over 2 minus 1, which is 1 over 2 times x raised to negative 1 over 2, which when you express this as a positive exponent, you get the 1 over 2 times x raised to 1/2. Then you can always bring the square root back to get the square root of x here. So, rule number 2 is about the derivative of a constant. So the derivative of a constant is a number. The derivative of any number is 0. For example, if they give you y equals 3, its derivative is 0. If y equals pi, because all of those are numbers, so the derivative is 0. Rule 3, addition rule. If you're taking the derivative of a sum, then it becomes sum of derivatives. So you kind of distribute the derivative to each function and then add them. For example, if you're asked to find the derivative of x squared plus x cubed, so you're going to take the derivative of x squared plus the derivative of x to the third. So the derivative of x squared is 2x plus derivative of x cubed is a 3 times x squared. So we use the power rule to get that. Similarly, if you are asked to find the derivative of x to raised to 1/2 plus x raised to negative 3, again, you take the derivative of each one of them and then you add those derivatives. So again, derivative of 1 over 2, the derivative of x raised to 1 over 2 is, so you drop 1/2 times x to 1/2 minus 1 plus, and then you drop negative 3 times x raised to negative 3 minus 1. So this gives you negative 4 as the exponent of x. Here you have negative 1/2. Most of the time we like to change exponents from negative to positive. So for this case, you just bring those two terms on the denominator, and then just change the exponent from negative to positive. So rule number 4, it's you're taking the derivative of a difference of two functions. So the derivative of a difference of two functions is the difference of derivatives. So you kind of distribute the derivative to each function and then take the difference. The same thing, if you take the derivative of x to the x raised to the 5 power minus 1 over x to the 1 minus 1 over x to the 4th. So this term is not ready to take the derivative yet. We'll have to change it to x raised to negative 4. Okay. So when you apply the derivative, then you just use the power rule in both cases, right? So you drop 5 times x to the 4th minus, and then you drop negative 4 times x raised to negative 4 minus 1, which you end up with 5 times x to the 4th plus 4 over x to the 5th. So rule number 5 is about taking the derivative of a constant times a function. Here we're going to assume c to be a constant. So you are asked to take the derivative of y equals c times f of x. So anytime you have a function, a constant times a function, you want to take its derivative. So you will bypass the constant. Okay, just go and take the derivative of the function. So the derivative of c times f of x is a c times the derivative of f of x. So here's an example. Y equals 3 times x squared. So y prime is going to be, so c is a constant, is 3. And then the function f of x is x squared. So this rule is saying, don't worry about the constant. Just bypass the constant and just go take the derivative of the function. So you keep 3. You take the derivative of x squared, which is 2x. And then you finally multiply 3 times 2, you get 6x. So now you have this. So to combine everything we learned so far, here we have subtraction, we have addition, and then we have constant in front of functions. So that kind of bring all the cases together. So you wanted to find the derivative of this function. So we have the difference, the sum. So we're going to take the derivative of each one of them, and then subtract or add. Okay. So then for this case, we have a constant times a function. So that rule says, well, just leave the constant alone, only take the derivative of the function. Here too, leave 6 alone, take the derivative of x squared. Leave 7 alone, take the derivative of x. We know the derivative of 3, which is a constant, is 0. So when you take the derivative of x to the 4th, it becomes 4 times x cubed. Derivative of x squared is 2x, and then derivative of x is 1. So after this, then you just multiply 3 and 4, you get 12 x cubed, and then 6 times 6 gives you, so you get minus 12x, and then plus 7. So you get the derivative of that function. So we have to remember the power rule of derivatives. Okay, always remember it throughout this entire section. So part B is the derivative of an exponential function. An exponential function f of x equals e to the x. Okay. So e to the x, e is a number, a real number, which is a 2.71 and 8 and so forth. And then we have another exponent. See, if a is not e, then you have a to the x, another version. Like here you can have like 2 to the x. Okay, so a is 2. So if we have cases like this, notice that these are not polynomials. Okay, a polynomial is this. So you have a x, a variable raised to the power that is a number, a constant. An exponential function, you have a number raised to the x variable. Okay. So these are two different things. So you cannot use the power rule here when you're taking the derivative of an exponential function. But we know the derivative of e to the x is e to the x. So that's the proof. The proof is given here, just to prove that anytime you're taking the derivative of e to the x, it itself e to the x. So the proof, if we use the limit definition of the derivative to prove it, okay, so the proof is here. It's been proven here. I'm not going to go to the proof, but we just have to know the derivative of e to the x is e to the x. So, for example, you have a function f of x, which is a 2 times e to the x plus 3 times x to the fourth, and then plus 7x. Since it's addition, we can take the derivative of each term and then add them up. So we know when you take the derivative of, since the 2 is a constant, you don't do anything with a constant. You keep the constant, you take the derivative of e to the x, which is e to the x. And then here you just use the power rule. You drop 4. 4 times 3 is 12. And then you reduce 1 by, you take away 1 from 4. You get 3. And then here, the derivative of x is 1. 1 times 7 is 7. So you get your derivative, f prime of x. So we're going to stop this video here. Thank you very much for watching.